Okay, this is a short set of notes. What I'm actually going to do is put this video on Google Classroom, but I'm also going to put this, what I'm using here. This is a Word document that I'm also going to attach, and you could either print this off or copy this down. But there's a video at the end that I want you to take some notes off of as well. So I'm kind of going to double do it, but I'll explain it as I go. This set of notes is talking about domain, range, and functions, and different types of functions. And so let's talk about domain and range because it comes up quite a bit. And this is true not just in Algebra 1, but in all the maths. They ask about domain and range, and it comes up from time to time. And so we really need to understand. Domain is all the different x values, or another way to look at it is how far horizontally or left or right a graph goes. And so either it's all the x values, and if you think about an axis here, a coordinate system, where x is the horizontal one that goes left to right, x goes out horizontal, that's the axis there. So it's saying all the different x numbers that you have if you're given points, okay? And this one right here is for points. And this is actually if you're looking at a graph or a picture, okay? And so if you're looking at points, this one here, or if you're looking at a picture. And the range is all the different y values or how far vertically a graph goes, okay? And so depending on if you're giving a whole bunch of set of data points, like these two examples here, you're looking at all the different y values. And how far vertically or up or down a graph goes, then you're looking at if it's a picture like so. All right? So, now, here is an example. List the domain and the range. Well, if I was writing and I actually had something to write down, which you should, the domain here would be 2, 3, 6. Why? Because I'm given a series of points, ordered pair, and 2, 3, and 6 are all the different x values, like it said. Now, just in case you have forgotten, every point is x comma y, 2x, 4y, 3x, negative 7y, and so on. And so the domain again, 2, 3, 6. The range, 4, negative 7, 10. That's all the y values. Oh, number 2, the domain, negative 1, negative 4, negative 1, and 0. Now, if your number repeats like negative 1 does, you don't write it twice. It's just negative 1. I already got negative 1 in there, so I don't have to write it again. So negative 1, 4, and 0 technically is your domain. And 8, negative 7, 6, and 0 is your domain. If the same number repeats in domain and range, that's okay. You just don't want it to repeat in the same just domain or repeat in just the domain. Now, this is looking at points. Now I'm asking you the same thing. List the domain and range of all of these graphs. And let's see if I can enlarge those. Or maybe I can just look at it like this. Alright, looking at number 4 here, and number 3. If I'm talking about the domain, since I'm given all these individual points and not a line, the domain is still going to be the x values. That's negative 3, because there's a point right there. There's negative 2, there's a point there. There's 1, because you have 2 points there. And then there's 4. So what's your domain? It's negative 3, 2, 1, and 4, because on this line goes up and down forever and ever. On this line here, there's a point. This line, there's a point. On this line, there's a point. Somebody in there making a mess. And on this line, there's a point. That's the domain. The range is the y's. And so now I'm on the y-axis. And so what's my range? And notice I always start with the smallest number. So I'm down here on the y-axis. Why? Because this is the smallest number. Negative 4, 2, 0. This line is 0, 3, and 5. The domain is the x-axis. The range is the y-axis. And so now I'm looking at the y aspect of this point. The negative 3 was the x coordinate. The negative 4 is the y coordinate. The negative 2 is the y coordinate. The 0 is the y coordinate. The 3 is the y coordinate. And so it depends on what you're given, which way you actually go as far as how you list your domain and your range. Now, number 4, and you can try some of these examples yourself, or I won't be able to get through all of them. Number 4, I'm asking you for the domain and range. And so the domain here, since it's continuous, meaning we got lines connected. Number 3, you had individual points. This is continuous. The way we write it is going to change. And so the way we're going to write this is, okay, now the domain, remember, it's all your x coordinates. And since you got a whole line here, I can't just say just these points right here because there's a whole bunch of them in there. So the way we're going to write it is different. My domain is going to be all the numbers that's between -3 and 3. You see that? As far wide as this thing goes, the smallest number is -3 and 3. So how do we write that? There's a couple of ways to write that. You could say x is greater than and equal to now, why did I use equal to? Because it's included. It's a dot right there. If there's an open circle, then I would have used just greater than and less than. Okay? Now, let's talk about the range. The range is, remember, the y-axis. So what's the lowest point on the y-axis? It's -4. You see that? There's something here on -4. And then the biggest number is 3. So -4 and 3 is the range. But let's talk about another way to write that so that this may be less confusing. If you've ever seen this, this is brackets and these are parentheses. Alright? The brackets means included. The parentheses means not included. Anytime you have a line going all the way through a point on the graph, then it's included. So you use brackets. Anytime you see something like this where you got an open circle, then that's not included. Lines that go on forever in a direction are infinity, but they use parentheses. And so another way to write the domain here would be -3, 3 with the brackets. This and this mean exactly the same thing. Over here I can say -4, 3, and those mean the same thing. Yes, this is what I'll accept here. This is the inequality way of writing the domain. Alright, let's go back. What about number 5 here? Number 5 will be the last one, and I'll let you do number 6 yourself. Alright, number 5 is asking for the domain and the range. Now the question is, with these arrows, is -4 the last number? No. Since the arrow means it keeps going on and on and on forever, how far or what's the smallest number to the left for this particular thing? That's right, it's going to go on for -infinity. And the biggest number going to the right forever and ever is +infinity. So how do we write -infinity and +infinity? That's the question. Well, let's see. -infinity, that 8 that looked drunk like it's laying down, but it's negative. +infinity, but both of these get parentheses, not brackets. Infinity always gets parentheses because it's not included. We don't know exactly where it stops, so we can't say for sure, so we use a parenthesis. That's for the domain on number 5. Now, what's the range on number 5? What's the range here? How far does this thing go up? See, we know it goes out forever, but how far does it go up? How far does it go down? And the question is, and the answer is, it's the same. It keeps going down for never, 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 and keeps going up forever, never, never. So this is the domain and the range on this particular one. Now, domain and range is important. It shows up on a lot of different things, and if you didn't get it, let's talk about it more in class. But we got to move on. function is a relation for which each value from one set of the first components of the ordered pairs is associated with exactly one value of the set of the second components of the ordered pair. Now, that's if we're talking about these things up here. So, in plain English, what that means for you is that in your X, in your domain, you don't have more than one of the same number. There's one-to-one from here to here for the X's to the Y's. And so you can't have two of the same X's with different Y numbers because that's not one-to-one. Okay? Now, and also, a function is an equation for which any X that can be plugged into the equation will yield exactly one Y. So if I put one number in, it's going to give me that same number every time. I should never put this number in and it give me two different numbers. Now, a visual of that would be something like this. If I gave you 2, 3 and 2, 6. What that means is if I have my little function machine here, is if I put a 2 in, it's giving me a 3 and a 6. That shouldn't work like that. If I put a 2 in, I should get the same number every time, every time. This would not be a function because it doesn't work correctly. And again, how does that look? Well, if we look at number 1, and if I ask you, is number 1 a function? The answer would be yes, it is a function because 2, 3, and 6 are all different numbers. All right? Now, I don't care what 4, negative 7, and 10, which is the Y's. I don't care what they are, but as long as all my X numbers are different, then it is a function. Number 2, negative 1, 4, negative 1, 0. You see how you got negative 1 and 8, and then you also got negative 1 and 6? This would not be a function because negative 1 gives me two different numbers, and so the answer is no. So normally, if you got the same X, it is not a function. Now, technically, they could give you the same point twice, but if it's X and it's the same, it's not a function. Now, there's different ways down here if you look at these. Yes or no. If a given set of points is what I just said, then it's a function. Sometimes people get tongue-tied or twisted on this thing. Now, what about the graph? A vertical line test. A vertical line, if it touches graph more than once, at any point, it's not a function. So if we look at number 3 again, if we look at this and say, is this a function? If I drew a vertical line right here, you see how you would be touching both of those points at the same time? So number 3 would not be a function. If I looked at number 4 and I drew a vertical line, notice what a vertical is, straight up and down. Notice on this vertical line here, you're touching here and here. It's not a function. However, if you look at number 5, any place I draw a vertical line, it's only touching once. So number 5 is a function. Okay, again, if that's something that's not clicking so well, let me know in class. But I got to move on. Alright, here's really where we want to go. And it's kind of small, but how to determine if you got linear functions. Okay, first of all, it looks like a line if it's a graph. That's how you tell if it's a graph. What about if you got an equation? These are very important. Your exponent has to have a power of 1 and only 1. X cannot be in the denominator. X cannot be multiplied with another variable because that means the power is not really 1. And X cannot be underneath the radical sign because that means the power is not really 1 when it's on a radical sign. You should know that, but we'll talk about that later. And so as I look at number 1 here, I can tell that this is a function because the X and the Y have an exponent of 1. Number 2 is not a function because look at that X, it has a 2 as an exponent. And number 3 is not a function because X is underneath the, is in the denominator. Now, I would like for you guys, when you see this online, to go ahead and click this. And this is how to tell if points or sets of points are linear by looking at a graph. See, now we moved into specific types of points. We're talking about how they're linear. Okay, running out of time. This video is about functions in general, and then we specifically got into linear functions. Make sure you click this and take notes off of that because it talks about something else that I won't be able to talk about. And Merry Christmas.